In this problem, we will review how to calculate both an empirical formula and a molecular formula. We are going to be doing problem number 4 from the practice worksheet number 7. The problem reads, a compound is 75.46% carbon, 4.43% hydrogen, and 20.10% oxygen by mass. It has a molar weight of 318.31 grams per mole. What is the molecular formula for the compound? Now, if you look at your notes, you will notice that in order to calculate a molecular formula, you first must calculate an empirical formula. To do that, what you need to do is convert all of the givens to moles. But because the givens are in percents, you're going to assume that you have 100 grams of compound. When you do that, all of your percents becomes grams. So you have 75.46 grams of carbon, 4.43 grams of hydrogen, and 20.10 grams of oxygen. And if you look at step 1 for converting or for empirical formula, you have to convert these to moles. So to convert something to moles, you use the molar weight on the periodic table. For carbon, it's 12.01. For hydrogen, it's 1.01 grams. And for oxygen, it is 16 grams. Using your calculator, you can calculate the answers to all 3 of these, and you do want to be careful with significant digits. For carbon, you're going to get 6.283 moles of carbon. The hydrogen, you get 4.39 moles of hydrogen. And for oxygen, 1.256 moles of O. Now, the next step on this, after you've converted to moles, the next step is to divide by the smallest number of moles. The smallest number is 1.256. So you divide each of those by 1.256. And in doing so, you find that for carbon, you get 5. For hydrogen, you get 3.5. And for oxygen, obviously, you get 1. Remember, when you get fractions, you have to clear them. To clear the 3.5, you're going to multiply by 2 to get a 7. But what you do to the the hydrogen, you have to do to all the other elements as well. So all of these numbers get multiplied by 2, and these are your new subscripts in the empirical formula. So your empirical formula would be C10H7O2. So looking at the problem, we have now an empirical formula of C10H7O2. Now we need to have the empirical formula to be able to do the molecular formula. So if you go to your notes, step 4 for molecular formula following empirical, step 4 is to calculate the empirical formula mass. So if you look at your empirical formula of C10H7O2, you're going to calculate the empirical formula mass. And you're going to do that by taking carbon's mass of 12.01 multiplied by 10, which should give you 120.10. Hydrogen is a mass of 1.01, and there are 7 in the empirical formula, so that's going to give you 7.07 grams. And oxygen weighs 16.00 grams. There are 2 of them in the formula. That gives you a total of 32 grams. Your total empirical mass is 159.17 grams. That's your empirical formula mass. That was step 4 for calculating molecular formulas. Step 5 tells you to take the given molar mass and divide it by this empirical formula mass. So you go back to your problem. The molar mass is given at 318.31 grams per mole. And we're going to divide that by our empirical formula mass, which we just calculated at 159.17 grams. When we do that math, we get approximately 2. What that is telling us is that our molecular formula is actually 2 times the empirical formula. So if our empirical formula was C10H7O2, our molecular formula is going to take each of those subscripts and multiply by 2. So C20H14O4. And that is how you calculate a molecular formula.